So in this video, we're going to discuss decision structures, which will be things like our if statements and all variations of that. So the topics that we're going to cover in this video, the if statement, like I mentioned, we're going to talk about if-else, the concept of nested if statements, the if-else if statement, logical operators, how to compare string objects, the switch statement, and kind of unrelated to those, but we're going to also talk about displaying formatted output with the printf method and the string.format method. So decision structures are something that allow us to break away from the very sequential step-by-step kind of program we've made so far and add in some conditional logic here. So like it says here, the programs we've created so far are sequential. We perform one step immediately after the previous step, right? So line 7 is performed right after line 6, so on and so forth. However, we often kind of only want the program to execute statements under certain circumstances or conditions, right? And we can do that with a decision structure. We've actually already seen decision structures when we talked about flowcharts. Remember, the diamond in a flowchart was a decision point where you ask a question. Here it is, is it cold? If the answer to that question is yes, you'll perform some kind of action. If the answer is no, you'll move on to some other action. We have also learned about Boolean expressions, which are very important when it comes to decision structures in programming. Remember that a Boolean expression is one that is either true or false. And we can use those Boolean expressions in our decision structures. So if the Boolean expression is true, the next statement will be executed. If the Boolean expression is false, the next statement will be skipped. So in order for us to determine, is this Boolean expression true or false, we need to use these things called relational operators. And these determine whether a specific relationship exists between two values. So we're going to use these operators inside our Boolean expressions. And this table here shows the relational operators that we use in Java. So we've probably all seen greater than and less than before. So 5 is greater than 1 would be a true statement, right? 5 is less than 1 would be a false statement. Greater than or equal to, less than or equal to. And the reason that I said the equals sign in Java is called the assignment operator, and we try to use the words, x receives some value rather than saying x equals some value when we're using that equals sign or the assignment operator, is because we actually do have an equal to operator and it is two equal signs. So this would say, is x equal to 1? That might be a question you could ask. You would use this operator here. And then if you remember the logical not that we talked about, we use the bang here or the exclamation point and an equal sign to say not equal to. And I'll show some examples of these in some of the code examples in the video that I'll post. So let's put all these things together. Boolean expressions, relational operators. Let's kind of put that together and flavor it with Java to talk about the if statement. So the if statement is an example of a decision structure, and this is kind of the general format of that if statement. So we use the keyword if, and then in parentheses, we're going to put our Boolean expression. We're going to have curly braces, and anything inside of those curly braces is our if statement body, right? Just like we have a class body and a method body, anything inside these curly braces of an if statement are our if statement body. So anything we want to execute, if this condition is true, we'll put inside these curly braces. We have another kind of statement called the if-else statement. And I'm going to do a couple of examples of these here in just a second. But the if-else statement kind of expands the if statement to say, well, if this is true, then I'm going to do something. Else, I'm going to do something different, right? So the format of that, the if header is the same. So we have the keyword if, We have the Boolean expression that we're going to use in our parentheses. We have our braces. Then we have the keyword else. We don't need anything in parentheses for else. It's just if this is true, do these things. Else, if it's not true, do something else, right? So we also have an else statement body with these curly braces, and we would put our coding statements here. So to do some examples of the if statement and the if else statement, I switched over here to IntelliJ, and I'm actually going to show you how both of those kind of work. So let's say that I have a variable. I'm going to declare an integer variable named x. Okay. So remember, to declare a variable, it needs a data type, and we know that this is an integer. So my data type for this variable will be an int, and we know that its name is x, which is the second thing we need for a variable declaration. Okay. I also want to give x a value of, let's say, 10. So we can do both of these things on the same line, where I declare the variable, and I also give the variable an initial value. Okay, so let's just show the if statement. So I can have my if statement say something like, if x is greater than 1, we can execute some kind of statement, right? So remember from the slides we were looking at, the format of our if statement is the keyword if, we have some Boolean expression, curly braces, and some kind of statement, right? So the keyword if, my Boolean expression is asking the question, is x greater than 1? If the answer to that question is true, then whatever I put in these curly braces will be executed. So I'm just going to put a print statement here. And just say something like x is greater than 1. Okay, so we know that x contains a value of 10, right? So in our minds, we know, yes, 10 is greater than 1. So logically, we should see this statement, right? X is greater than 1. So let's run this code. And we'll look at our output, and we do see that my message was displayed. What happens if x is not greater than 1? What if I change x to be 0? So now we know that x has a value of 0. My program is going to get to this statement and say, okay, is 0 greater than 1? The answer to that is no, right? So this will not be executed. It will be skipped, right? Because this is only going to be executed if whatever we've put in our Boolean expression turns out to be true. So if I run this, we'll see that my program runs, but I have no output, right? Nothing happened. So that's why kind of one of the reasons that we use the if-else statement. So this gives us a little bit more freedom here to say, okay, well, if this is true, execute some statement. If it's not true, execute some other statement or statements, right? So we know x is not greater than 1. So I'm going to say else, and I'll have another print statement here. Okay, so let's kind of walk through this. X has a value of 0. If 0 is greater than 1, print this out. Well, we know 0 is not greater than 1, right? So it's going to skip that. But it's going to say else, if x is not greater than 1, print this out, right? So if I were to execute this, we'll see the message x is not greater than 1, right? So I'm going to change x back to 10. Now what would happen here is it's going to say, is 10 greater than 1? Yes, it is. So this will be executed, and my program will immediately skip over my else and start running whatever is after this if-else statement here. Okay. So I'll just put a message here that says out of the if statement, just to show you that this is not executed, right? It's skipped over because this one was executed. So that's if and else. We do have a concept of something called a nested if statement, and this is used, fairly often, but it should be used with kind of discretion, right? You can nest an if statement inside another if statement. So that would look something like this. So if condition A is true, we'll do something. We can put another if statement that will execute only if the first thing is true, right? You can test a series of decisions this way, but it can be very complicated if you start nesting too many. And I will post a code examples video that shows a lot of these concepts, so keep your eyes out for that video. We also have the if-else if statement, and this lets us test a series of conditions in a much simpler way than nesting a bunch of if statements, right? This is okay. This is not a bad thing to do, nesting if statements. This is a lot more clean and easier to read, so I prefer this way personally. But you can test multiple Boolean expressions by using this type of statement. So if I go back here, let's say we want to ask the question, is x greater than 1 and is x greater than 100, right? One way we could do that is we could say, okay, well, if x is greater than 1, we'll say x is greater than 1. Else if x is greater than 100, we can say system.out.println x is greater than 100. Right, so I'm testing a bunch of different conditions here, and you could have as many else ifs as you wanted, rather than having to nest a bunch of if statements. And the code examples video, I'm going to keep referencing that, will have some good examples of an else if statement. So let's talk about logical operators. Let's say we want to actually combine two Boolean expressions, two or more expressions, into one Boolean expression, right? How would we do that? Or how would we reverse the logic of an expression? And we use something called a logical operator here. And these here on the left are the operators that we use in Java. And luckily, we've already talked about logical operators before. Logical and, or, and not are the three that we're really concerned with in this class. But remember, and means both things have to be true. Or means only one needs to be true. Not will reverse the logic of a Boolean expression. So some examples here. Is x greater than y? And is a less than b? So we could put both of these things into one Boolean logical statement in an if statement, right? So I can actually do that. So I could say x is 10, y is 1, a is 5, and b is 50. All right, so I could now ask, is x greater than 10? We'll say, is x greater than 5? Or let's do, is x greater than y? That's what we'll do. Is x greater than y? And is a less than b? Okay, so we want to combine both of those things into one Boolean statement rather than have to do a bunch of else ifs. So to do that, we can combine those into one Boolean expression, right? And this is the question that we want to be asking, so that's how we're going to write our Boolean expression. So is x greater than y? That's the first part. And is a less than b? So if we go back to our table here, our logical and operator is 2 ampersand signs. So I'm going to say, is x greater than y? And is a less than b? If that turns out to be true, if both of these are true, then my statement will be executed, right? So we know based on these numbers, both of those things are true. So we will say x is greater than 1. And I'm actually going to copy this. For my output. What happens if I change one of these things? So let's say y is 100, right? Now we know that x can't be greater than y because y has a value of 100. A is still less than b, but x is not greater than y. Because this is logical and both of these things are not going to result to true, my statement won't be executed. So if we run this, we'll see I have no output. That's where the logical OR can come in handy, where only one of these needs to be true, and the logical OR is 2 pipe characters, which is right above the enter key. So now I'm saying, is x greater than y, or is a less than b? Right? So if I were to execute this, because one of these is true, I will get my output shown. So that's the first example. Here's an example of logical OR. So I'm saying, is x equal to y? Here's that double equal sign. Or is x equal to z? And then our negation operator, right, our logical not, reverses the truth of an expression. So an example of that would say, is the expression x is greater than y not true, right? And I will have a good example of that in the coding examples video. Here's a truth table, and if anyone's taking math for computer science, you'll probably see a truth table sooner than later. But basically, truth table for logical AND, or the AND operator, the only way that the logical AND will return true is if both of my statements are true, right? Any variation other than 2 trues will always be false. The OR operator, everything will be true unless they're both false. And the NOT operator, again, it reverses the truth, right? So something that is not true is false. Something that is not false is true. So let's talk about checking numeric ranges with our logical operators. What if I want to say, is x in between this value and this value? And the way we can do that is by using the and or operators. So if we wanted to if we want to determine if a number is inside of a range, like if x is between 10 and 20, that's inside of a range, that's when we would want to use the and operator. If we want to determine if it's outside of a range, it's best to use the or operator. So something like if x is less than 10 and greater than 20, that's how we would do that. So the reason that we do that, and I'm going to try to do some art skills here. Let's say this is a number line. We'll have 0 and 10 on our number line. Now let's say the first question I want to ask, is x between, forgive me for this writing, is x between 0 and 10? Right? In order to answer this question, we would want to use the logical and, or the and operator, right? Because we are determining if x is inside of a range. It's in the range 0 to 10. So we would just say something like x is greater than 0, probably greater than or equal to 0, which in our Java terms, I want to draw that correctly, x is greater than or equal to 0, and pretend like that's a good ampersand, x is less than or equal to 10. Right? And we can kind of make sense of that. We can see, okay, x is greater than 0, and it's less than 10. So we're determining if it's inside this range, right? Now let's ask the question, is x less than 0, or is x outside the range 0 to 10? So here's my number line again. Here's 0, here's 10. So now I want to say, is x outside outside 0 to 10 range? And we'll just pretend like I can write legibly. So to do that, if I used this AND operator, right, if I said, okay, well, x is less than or equal to 0, well, we wouldn't even want equal to, right, because we're determining if it's outside the range. So if x is less than 0, let's do and see if this makes sense. That's unacceptable. Okay, we're just going to pretend like these are legible ampersands. Nobody can draw these. X is less than 0 and x is greater than 10. And you may start to see why this is logically impossible. X cannot be over here and over here at the same time, right? Because that's what this is saying. X is less than 0 and it is greater than 10 at the same time. It can exist on the outside, right? It could exist on the inside. X could be greater than 0 and less than 10, but it can't be on the outside. That's why we need to use logical OR. So what our OR operator says, x is less than 0 or it's greater than 10, right? So x is either over here or it's over here, but it's not in both places at once. So that's kind of why we do that. And there is a good example of this in the code examples video. So let's talk about comparing strings. We've kind of talked a little bit about comparing numbers with our operators, right? This is our equals to, we have less than, greater than, all these things. How do we compare strings? Because we've talked about in the last video that strings are objects, right? Strings are reference variables. They don't actually hold the literal string itself, they hold a reference to a string object. So with primitive variables, I can use those, I can use these operators here. 1 is equal to 1, right? I can say that because x and y would both contain the number 1. But with a string, they're going to contain memory values, not the actual string. So if we want to compare if a string is equal to another string, right? Is the name Will the same as the name Will? How would we do that? Well, the string class has a method that we can use called the equals method. And there is a good example of that in the coding examples video. We also have an equals ignore case method, right? So let's say I'm comparing the name Will that's all lowercase and the name Will that's all uppercase. Well, depending on the program you're writing, maybe those are the same name to you. So you can use the equals ignore case method that just ignores the fact that one's lowercase and one's uppercase, and instead just inspects the characters themselves. So we've talked about kind of a decision structure that's very binary, right? It's yes or no. If this thing is true, then do this. Otherwise, do something else, right? That's kind of a binary decision structure. We do have in programming a multiple alternative decision structure. So something like this. I'm going to ask the question, what month is it? And multiple alternative decision structures say, well, based on a provided value, you could have various outputs. So it's not really yes or no with these, it's more of what value am I using. So let's say the number 1 would be January, the number 2 would be February, the number 3 would be March, so on and so forth. And then if there was no number provided or somebody provided like a random number outside that range, you could just display some kind of error message, right? So that's kind of how a multiple alternative decision structure works. And how we do that in Java is with the switch statement. So the switch statement is in some ways similar to an if statement. In other ways, it's very different. What we do with a switch statement is we use the switch keyword, and then in parentheses, we're going to put whatever our expression is, just like that's very similar to an if statement. But inside of our braces, instead of just putting statements here, we're going to provide cases and specific values. So, if the value is this thing, we're going to do these. If we have a value of this, we'll do these things, so on and so forth. Default means that there was no relevant value provided, right? Watch the switch statement section of my coding videos for a good example. Notice, though, these colons at the end of my cases. That's one of the weird syntax things about Java to keep in mind. Formatting output. So let's say that you want to format your output somehow. If you have a double, we talked about doubles being our decimal data types. If you displayed a double, it could have as many as 15 decimal places. If your program is using doubles to, represent money, right? When you look at a monetary value, at least in dollars, you don't have 15 decimal places. It's usually 2 decimal places for the cents, right? We can use output formatting to say, okay, I don't want 15 decimal places, I just want 2. And the way we can do that is with 2 different methods, the printf method and the string.format method, which both work the same way, essentially. So the printf method looks like this. So system.out.printf. We've already seen system.out.print and .println. This one is .printf for print format, right? So notice, though, that in my parentheses, I don't really have my message per se. I've got 2 things here separated by a comma. So the first thing is going to be a string that contains, maybe some message for my text, any kind of special formatting that we want applied, or both. On the right is going to be our arguments that are actually going to be formatted, right? So if over here I say this decimal is going to have 2 decimal places, over here is where I would specify what decimal I'm actually talking about. So a format specifier, which I've used that definition, that's just a placeholder for a value that will be inserted into the message when it's displayed. And we do have some syntax of how that format specifier works. It will always start with a %sign. And then we'll have some optional things here. So these things inside these brackets are optional. Flags basically cause our value to be formatted in a bunch of different ways. After our flag, we can specify a width of how many things we want this to be. Our third optional thing is precision, and notice that it has a decimal before it. And this is basically how many decimal places do you want your numbers to be rounded to. And then the last thing is a conversion character. And a conversion character just tells you, what kind of variable are you formatting. So here's an example. Let's say that I have some kind of number and I want it to look like, maybe I want this number to be comma separated. I want it to have only 2 decimal places. And I want a new line after my message, right? So how you would do that using the printf method is, notice my 2 things here, right? Notice the comma that separated it. Over here is my variable. See how I have double number here? I'm referencing that variable here. So let's talk about this format specifier, which is this stuff right here. So what I'm saying is my message is going to say the words, the number is with a colon, and then here's where I put in my formatting, right? This looks weird. This will not actually be displayed in the message. Remember that format specifiers are placeholders, right? So all of this stuff that I've highlighted here will be replaced by whatever I specify after the comma. So in this case, number, or this decimal value here, is going to be formatted according to this rule and inserted into my message. So what's it going to look like? Well, our flag, remember flag was the first thing after the percent sign. All format specifiers start with a percent sign. That's how Java knows it's a format specifier. So, comma separated. My flag here is just a comma symbol, which tells Java that I want this number to have commas in the thousands place. I want this field to be 12 spaces wide. I want it to have 2 decimal places, and it's a floating point number, right? It is a double, but a floating point number just means that it has decimal values, right? So that is the F here. That's my conversion character. So my 3 things, my flag, or I guess my 4 things. This is my flag, the comma. 12 was the width of the field. 0.2 was the precision, and F is my conversion. So if we go back, here were my things that I need. So in the example I showed, comma was the flag, my width was 12, my precision was 0.2, meaning 2 decimal places, and the conversion character was F for a floating point number, right? And what that will look like when it's displayed is it would say, the number is, I'm going to try to write this out. The number is with a colon, and then we're going to have our decimal here be formatted. So it's going to be 12,000, comma, because we specified comma separated, 345.68, and I'm going to have a new line at the end because I do have a new line character here in my message, right? So that's what format specifiers do for us, and the printf method is what allows us to use format specifiers. Again, reference the code examples video. I do have a good example of this. The string.format method works the exact same way as the printf method, but instead of printing the output to the screen, it's going to return the reference to a string that's been formatted that way, right? So instead of displaying this to the screen, it's going to store this in a string object, and then you can use it whenever you want, right? So the number is 12,000 whatever is going to be stored in a string object, and the reference to that string object will be stored inside of formatted num here. And, there may be different reasons why you would want to do one of these methods over the other. If you use the string.format method, it allows you to reuse that string over and over again. Whereas if you use the printf method, it will only display it to the screen, one time, unless you type all of this out again. So if there are any questions on this material, please send me an email. I will post the code examples video along with this one, just so that you can, see some better examples of how these concepts work in action. And I will post all of the code files from that video so you can take a look at those whenever you want.